All right, ladies and gentlemen, it's Mrs. Hoekstra. Time to do lesson 2 of our second module, module 2. In today's lesson, using the number line to model the addition of integers. Using the number line to model the addition of integers. And the essential question today, what does the absolute value of a number tell you? Right? What does the absolute value of a number tell you? We talked about absolute value yesterday, so hopefully you can remember. If not, we'll make sure we have it really solid today. All right, exercise 1, real world, right? Real world, because a lot of times I hear in class, Ms. Hoekstra, when am I ever going to use this? No one ever uses these things in the real world. Well, yes, they do. Suppose you received $10 from your grandmother for your birthday, right? You spent $4 on snacks. Using addition, okay, let's suppose you don't know how to subtract. You've never been taught how to subtract, but you received $10 and you spent $4, right? A number sentence that represents this situation. Well, when you receive $10, that's positive money, right? Woohoo, we like getting money. We received $10. And I only know how to add, because that's what it says, using addition, right? We're going to spend $4. Well, spending is negative money. We're going to spend $4. All right? So what would this look like? What would this look like? It's going to look like what? You'll have $6 left over. All right? How would you do this on a number line? So based off of what we did yesterday, right? Based off of what we did yesterday, we're going to start at 0, and we're going to go to the right 10, right? Because there's my $10 I got from Grandma. And then I'm going to come back 4, and I'm going to end right here, right? I came back 4, and I ended at 6. And there it is on our number line, right? Just a quick review from what we did yesterday. All right, well, example 1. Let's keep doing this, and let's just kind of make sure we have this whole idea down really, really solidly. It says we're going to complete the following steps if we were adding -2 plus 3, right? I'm actually going to write that up here, -2 plus 3. So where do I start? I place the tail, the start of my arrow, on 0, right? I'm going to place the tail on 0. There it is. Draw the arrow 2 units to the left of 0 and stop at -2, right? I'm going to stop at -2. The direction of the arrow is to the left, right? We went left since we were counting down, right? Because it was negative. Negatives are to the left of 0. Start the next arrow at the end of the first arrow or at -2. So we're going to start here. Draw the second arrow. How far are we going to go? 3 units. We're going to draw that second arrow 3 units to the right since you are counting up from -2. So we're going to go 3 units. 1, 2, 3. Stop at 1. Circle the number where the arrow ends. In this case, it ended at 1, right? There we go. Okay, well, it says we're going to repeat that process A through F. We're going to do all of those steps again, but this time we are adding 3 plus -2. All right, so the first thing we're going to do, we're going to start at 0, make our tail. Since 3 is positive, I'm going to go 3 units to the right. 1, 2, 3 units to the right. I'm going to now start my next arrow where that one ends. I'm going to move 2 units to the left. 1, 2, and circle my answer. And I get 1 again. So what can we say about the answers to -2 plus 3 and 3 plus -2? What can we say about those answers? Well, a minute ago, that gave me an answer of 1. And just now, this one gave me the answer of 1. Well, what can I say? Well, I can say that, right, they're the same, right? I'm going to get the same answer. They're equal to each other. Does the order, this is kind of important, does the order matter? Can I add them in any order I want? Yes, I can. Adding in any order, it doesn't change the answer, right? I can add in any order and get the same answer. Okay, that's called the commutative property. C-O-M-M-U-T-A-T-I-V-E, commutative property. The commutative property says you can change the order. Underline the word order. That's the key to that one. Right? I can change the order. Doesn't matter. All right, let's have a story problem for the numbers -2 and 3. So I'm going to use golfing. I don't know if you've ever golfed, right? But a golfer was -2 strokes below par, right? They're below par. They took 2 strokes less than they needed to. But the next hole, right? The next hole, he or she took 3 strokes. Okay? So a minute ago they were 2 strokes below par. Now it took them 3 strokes. So, you know, they're not doing so hot maybe. I don't know. Depends on how many strokes were needed for that particular hole, I guess. All right, example 2 on the top of page 15. How does the absolute value determine the length, determine the arrow length for -2, right? So let's talk about absolute value. Remember, math people, we're too lazy to write that whole word out. Absolute value, I said, was that crazy weird symbol that looked like that, right? There's what an absolute value. Absolute value of -2 looks like that, where we've got those lines going on either side of it. All right. Well, if I said, hey, how long is just the arrow of -2? Well, again, you would start at 0 and you would draw an arrow and it would bring you right to here. But how long is that space, that little spot right there? Well, it's 2, right? Because the absolute value of -2, that arrow length is 2, right? That's the length of the arrow. Well, what would I say then about the absolute value for 3? Well, first of all, how do you write the absolute value for 3? Absolute value of 3. And if you drew an arrow, right, how long is that arrow right there? It's 3 units. The absolute value of 3 equals 3, right? Because that is the length of the arrow. How does the absolute value help you to represent -10 on a number line, right? So -10, what do I know about it? Well, if I said the absolute value of -10, that equals 10, right? That's the length. That's the length of the arrow. Okay? What else do I know about -10? Well, I know the length of the arrow is going to be 10. How do I know which direction I'm going to go from 0? Am I going to go to the left or to the right? How do I know that? Well, that's based on that negative, right? Because it's negative, the negative tells me that I'm going to move or draw my arrow to the left, right? Move the arrow left, because that's what negative tells me. Negative tells me left. Or if this was a number line that was vertical, we would say it would move it down, right? That's what that would tell me. All right, top of page 16. It says exercise 2. You see those 2 problems right there? These 2 right here. I want you to pause the video. Right? I want you to pause the video. I want you to do the problem, just like I've done my last 2 examples. And when you are done with that, check your answers with me and come back when you are ready to start exercise 3. Go ahead and hit pause right now. So take a look at my two answers there. I said the first one was -2, right? And there's my arrows to show my work. And then my second one, I got to add a -8 there. My second one, I got an answer of -5. Okay? How'd you do? Did you get them both right? If you didn't, talk to me when you come to class. All right? Let's make sure we get this and we know how to do these for these number lines. Example 3, finding sums on a real number line model. They don't mean like, hey, it's a real model, it's a number line that's real. It is about real numbers. Okay, there's different types of numbers. This one's about real numbers. So take a look at the numbers that were given to us, right? Where did we start? What number did I start with? And where did I go from there? So what numbers do I have in this problem? Well, I've got a 5, I have a -2, and I have a 3, right? So I got to write an equation to express that. What's the number I started with? Well, if you notice, this starts here at 0, so I started with 5. At the end of the tail for 5, it brings me to where? -2, so I'm going to add -2. And the end of the tail of the -2 brings me up to the 3, and so that's how I get that. Notice where the 3 ended. Where does 3 end? It ends at 6. Okay? So 3 numbers that we had, I just wrote those down a minute ago, was 5, -2, and 3. I'm going to drop down to can we make a connection between the sum of 6 and where the third arrow ends on the number line? Well, since the third arrow ends on 6, that must mean the answer is 6, right? Since the third arrow ends on 6, the sum must be 6. Okay? Well, let's talk about, keep going on this. What's on the top of the next page? Would the sum change if we changed the order? What if we changed the order? Right? What if we had gone -2 plus 3 plus 5? Would it change the answer? Remember what I said about a page back? I said, no, we can have it in any order, right? We can add these in any order. So, no, the order can change and the sum will stay the same. Right? The sum's going to stay the same. Doesn't matter. Would the diagram change? Let's think about that. Would the diagram change? So I'm going to just quick draw a line and let's think about this a minute. Okay, so a minute ago on the other side, I started at 0 and I went to 5. Now I'm going to go, what, to -2, right? And then from -2, I'm going to go 3. And then I'm going to go another 5, right? Does that change anything? Well, the arrows have changed, right? The arrows have changed in the order I have the arrows, but did the answer change? Right? The diagram's going to look different, but the answer is going to stay the same. The diagram looks different. The diagram looks different, but the solution, the answer, right? The solution, the answer is the same. Order doesn't matter. The order doesn't matter. All right, well, that's it for lesson 2. Hope you enjoyed it, and I will talk with you later. See you later.